Once we receive these samples in the lab, we get hundreds of these samples every day. So once we receive the kit in the lab, we actually open the box, open all the boxes, and assign a control number to both the CIF and to the oil sample bottle so that we know that these two go together. Our clerical staff starts to enter this data into our computer while our technical staff starts to work on the analysis of this. So we have hundreds of these that come in every day. So because we have a control number assigned to them, we enter the control number into the computer. It's recognized by our ICP. So when we do the analysis, we can mesh all of those things together. All right? So the first thing we do with the oil sample that you've sent us is we draw out a small amount of it. We put it into a test tube that looks like this. And we put some solvent in with it just to dilute it so it's easier for us to get it through the instrument. So the diluted sample now is put on an auto sampler in our ICP, our inductively coupled plasma mass spectrometer, and the instrument draws that sample into it through this peristaltic pump here on the front of the instrument. It draws into here, flows up here, flows across a flame. What the flame does is it basically atomizes all of this oil. So all of the wear metals that are in the oil are atomized. We have detectors here that pick up the energy from this process and they evaluate the energy. They evaluate it for two things. They look at the wavelength of a particular metal. So every transition metal has a slightly different wavelength when this process happens. So it picks up on what that wavelength is, but it also picks up on the strength of that wavelength. The strength of the wavelength tells us how much of that metal is in the oil sample. So we've got the sample through the instrument, do the process of atomizing that oil sample to pick up the wear metals that are in there, the type and the concentration, and then that data is dumped into the data processing cycle, and from that we merge that information into our laboratory information management system, our LIMS system, and then we can evaluate that within our LIMS system. So how do we evaluate that? We look at all of the wear metals, 12 or 15 wear metals that we're actually looking at, and we look at your samples data versus all of the samples that we have in our database that are the same engine type as yours, approximately the same number of engine hours as what's on your engine, and the approximate oil hours that are the same as the oil sample you sent to us. And we use those three parameters to grab all of the data in our database that match those three criterion, and then we compare that average against your specific data to tell you whether or not your engine's making more metal or making less metal against the average. And that's the first thing we do. That's a comparative statistical analysis that we do. The second thing that we do is the much more important part of that, and that's to compare the trend that you're doing. So we look at the last sample or the last several samples, if we have any, and we compare that to the new sample. So if the trend is going up, we note that. If it's going down, we note that. If it's staying consistently the same, that's a good thing. We also note that. And we comment on that. If it's going up, exceptionally up, we'll make a comment about where we think that metal might be coming from and what we suggest you do to proactively address what looks like a growing problem inside of your engine. And we do that for all of the metals that we've tested for. We look at all of them. We look at the averages of all of them. We look at the trend of all of them. And we comment on what we think is happening in your engine and where that thing might be happening in your engine. Right? So we use comparative statistics, we use trend analysis. The third thing we do is that we look at it more of a holistic kind of approach. We say, even though you may have these slight anomalies in the sample data that you have versus previous data or versus the average data, even though you may have some anomalies, they may not be a problem. So we have an overall, we call it an alarm meter, that tells you, your sample's green, sort of like a stoplight. Your sample's in the green, it's yellow, it's a caution, we need to be watching, or it's red. We've got a problem, we've identified a problem, you need to proactively deal with this problem. So you can look at individual data, you can look at the comparative data, you can look at the trend data, you can look at our comments about the sample and what we think the data means. And if you're not interested in any of that, you can just look at the little stoplight that we have up at the top, green, yellow, or red, and it will tell you whether you need to be concerned about the data that we've received for the sample.